you'll be able to write a linear equation and be able to write a system of linear equations. When writing a linear equation, the first thing we want to do is to write an equation. Um, it makes it a lot easier to do the second and third steps. So we want to write that down. Write an equation to start with. And this is our boundary line. So in this example, we have a dashed line that we will be writing an equation for. Second, we want to um, determine if which inequality we will use, less than or greater than. And that's what we do for that one is we test a point. Now, that'll be a key part for not only writing an equation, but also graphing, but writing an equation. The third thing we want to do is the equals or not to equal. That is the question. That is the last question. And so we'll determine that by that dashed line. So for this example, what we're going to do is write that equation for that line. So we'll do y equals mx plus b first. So our slope is a rise of 1 and a positive 2. So that would be a rise of 1 over a positive 2 in the denominator, x, and our y-intercept is 1. So now that we have our equation, that's our boundary line, just to get the line so that we know which one it is. So now we need to determine, is it a greater than sign or less than sign? Now, I caution you that these will get more complicated when we get into more complicated like linear equations and after linear equations, quadratics. So this applies to all those. So you want to test a point. That's a key part of this is testing a point. So notice how I left a opening here where my inequality will go. So I'm going to test a point. Now, they have a point 0, 0 here, which we could test, and it would be the easiest one to do, but that would be on our non-true side, and it gets a little tricky. I'll show you that after, but what I like to do is pick a point that's on our side that is shaded, and this is any point over here will make our statement true, so we don't have to rethink about what's not true, we just have to think about what is true. So I could pick any point over here, but I like to pick and look for one that is the same because then I don't have to really think hard about where it goes. So I found this 3, 3 point right here. And so I can just substitute 3 and 3 in for x and y. And what I want to do is test, I'll substitute those in, and 3, that would be 3, 1.5 plus another one would be 2.5. So now what I do is I think about, well, what inequality would make this true? So I know that 3 is greater than 2.5, so I'll put a greater than sign, and I just keep bringing it up because that will be true for all of these because that's on the true side. So now our last one is it equal or not equal? And so this boundary line is a dashed line, so that means it's not, we don't include the equal sign. And this is our inequality for this linear inequality. Now, I'm going to go back to y1/2 x plus 1. So I'm going to use this point 0, 0 just to test it out. And it is on the non-true side, so 0 times 1/2 is 0 plus 1 is 1 and 0. So being that it's on the non-true side, I want to make this statement now untrue. So that means 0 is less than 1, so I want to put a greater than sign, bring it all the way up, greater than. And notice how it matches the one up here. But what's tricky about using this strategy is that a lot of people will mix that up and want to make it true. So I always kind of suggest pick a point that is on the true side. And then you don't have to really think hard about it. You just have to make the statement true, true, and bring it all the way up to true. All right, so now let's go to a system. So we're going to do this same thing. We're just going to do it twice. Now what's tricky about this one is to think about this shading. So we have a shaded part, which is a system. Remember, it's a system. So that means on our dashed line, it is on this side. So our shading is all on this side. And I'm going to keep going because it's all on this side. Now remember, it's a system. So this shading is not, the solution is not just one of them, it is both of them. So now let's take a look at this horizontal line. And that shading will be this one up here on the top side of that. So what I'm going to do is I'm going to shade all of that part over on this side, the top side. So now I have my shading. So I think I'll start with my horizontal line because I like that one. So I'm going to write the equation for that. So y equals, and it's a 0x, so that zero slope zeroes out, and I have a -2 as my y-intercept. So now I need to pick a point that's above this line. So for me, I'm going to pick, for this one, I'm going to pick 0, 0, because that's the easiest one. Well, if I substituted 0 in for x, that's 0 times that 0 slope is -2 over here on the right-hand side. 0 for the y is 0. And because it's on my true side up here, I'm going to make this inequality true. So 0 is greater than -2. And so I'm going to bring that up here to my, oh, I forgot to rewrite it, to -2 is greater than our -2. Now it's this horizontal line, so it is a solid line, so I will include that equals for this one. And that is my first equation. So I'm going to bring that down here into my system. So y is greater than or equal to -2 is my first equation. So my second equation does follow that y equals, so it has a 0 for my y-intercept. Bring down my plus x, and my slope is up 1 over 1. And it's a positive slope, so it's just y equals x. So that's my boundary line, but I want to rewrite my equation to find my point that's true. So now 0, 0 doesn't work right now because it's on that borderline, and I don't want to use that one to get my equation, my inequality. So I'm going to pick a different point, and that point is going to, for me, it just has to be on this side, this bottom side. So I'm going to pick, I don't know, 2, -1 down here, over 2, down -1. So I'm just going to write that 2, -1. So because none of the pairs ones work, and I get kind of confused. For me, I get confused when it's negative and negative. One's positive, one's negative. So I just changed one, use one that's a different number when they're opposites. So the x is 2, so we need to make sure that that's in the x place. The -1 is the y, so -1, and I want to make that true because it's on that true side over here. So that would be -1 is less than 2. So I'm going to bring that up to my inequality. And now it's got a dashed line, so I will not include the equal sign. And there is my second equation. So y is less than x. And that is my system for this double shaded area covered here. So now for another example, we have two more. Number 4, if you notice, is a special case. So we'll get to that in a second. So I know that the vertical, oh, so let me do the shading here. So this is the shading on the left-hand side for this one. And then I'm going to change color because last time it was a little tricky to tell which one was shaded. So the dashed line is going to be this, and I'll make it kind of a red dashed line for myself to remember that that's the red one. So for my equation with the vertical line, that is a undefined slope, so it's x equals 3. And now I'm going to pick a point, and this point over here, 0, 0, works really nicely. Ooh, it also works nicely for the red shading. So 0, oh, I need to get that x. Hold on a sec. I forgot to rewrite it. X and 3, so substitute now 0 in for 0, 0. There's no y, so I don't need to substitute a 0 for the y. And 3, so 0 is less than 3, so I'll bring that up here. And it's the vertical one is a solid line, so we also include those points with our equals. So it's x is less than or equal to 3 is one equation. And our second one, y equals, and my y-intercept is -1, so -1. And our slope is, I have a point here and a point here. So that's a rise of 2 and a run of 3. And it's a positive slope. So 2 over 3 is rise of 2 and a run of 3. And now I'm going to do my inequality by picking a point. And that point I'm going to use 2 is 0, 0. So 0 and 0 minus 1 is -1. So that would be 0 is greater than -1. So I'll bring that inequality up to my linear inequality. And it's a dashed line, so I do not include that. So here's my second one. So now I need to bring them all together, both of them together, into our system. So x is less than or equal to 3, and y is greater than 2/3 x minus 1. And this system is the solution for this shaded part here. Now remember, it's not just what's in the box, it's outside the box. That's what those arrows mean, is it continues out, and all those shaded parts are out there. And this line continues out, dashed of course, and continues out this solid line. Oh, so I should also include this solid line as our solution. Now this point right here, I do not include that one, so I'm going to grab my eraser and erase that point. So it is not included in our solution, just the line just above that would be. Notice I should shade really close to that line, but I won't include the points on that line. So now when I think about the example number 4 down here, this is the special case. So you want to think about what is overlapping. Remember how up here at example 3, we thought about what was overlapping, and on the dashed line it was above it, and on the vertical line it was to the left of it. So there is no shading on this, meaning that there is no solution that would work. So there's no overlap. So that means our shading for the one on the right-ish is over here is the shading to the right. And to the other one, the shading is to the left. So there's no overlapping. So we kind of have to think about that as where they're not overlapping. So I will start with my red one, and that would be y equals, as an equation, my y-intercept is -3. Bring down my x, and our slope is a negative slope, so we have to watch out for that. So now I have a point here and here, so that would be a rise of 2 and 1, so it would be -2/1, so our slope is -2. Now I'm going to test a point to find that the shading part, the inequalities. So I'm going to do -2, -1. And notice I'm not picking any on the line because that's dashed. We'll do that with later. So -2, a lot of times I like to write it so that I know which one's which, -1. So -2 goes in for the x. So -2 times -2, I like that, minus 3. And -1 is the y. So -1 and 4 minus 3 is 1. So -1 is less than 1, so I'll bring my inequality all the way up. It's a dashed line, so I use this linear inequality for my red one over here. My blue one is y. Ooh, I notice that they are parallel, so that is why there isn't any double shading. So if they're parallel, that means they have the same slope, but different y-intercept. So I can find my y-intercept of -1 and y equals -2 times some number minus, x. That's my next step. -2 times some number minus 1. And my point that I like this one, 0, 0 right there. So 0 and 0, so 0 and -1. So that means 0 is greater than -1. Just bring it on up all the way to our linear inequality, dashed line, so we do not include the equal sign. And here is our system. So in black, our system is y is less than -2x minus 3, and y is greater than -2x minus 1. Notice I used the word and correctly because when there's a system, the shading is the overlapping. And so up here is an overlapping, but we do see an overlapping. Here the and is our special case where this system, there is no overlapping, so there is no solution would be the answer. But to write the system that has no solution for these two lines, linear inequalities, would be this y is less than and y is greater than.